Okay, welcome back. When we left off last time, I had asked you to answer these questions on your own and said we would go over them next time. So, what's an ion? Well, an ion is an atom, we said, that has lost or gained electrons so that it no longer has the same number of protons and electrons. This means it has a charge. So, if it loses electrons, it'll have more positive protons than negative electrons. It'll be a positive charge. If it gains negative electrons, it'll have more negatives than positive protons, so it'll have a charge. So how is a positive ion formed? When an atom loses an electron or electrons, which are negative. So it's losing negatives, and it has a full outer energy level of 8. So when it loses those negatives, it becomes a positive. And how are the negative ions formed? Well, they're formed when atoms gain negative electrons, have a full outer energy level of 8. Okay. What two materials do ionic compounds occur between? Metals, which make positive ions, they're on the left side of the periodic table. They have 1, 2, or 3 valence electrons, and we said they would be losing those electrons. And then the nonmetals gain electrons. They had 5, 6, or 7 valence electrons, so they can gain 3, 2, or 1 electrons, and they become negative. How is an ion formed? When opposite charged ions, like a magnet, attract each other. Okay. So here's the periodic table again. I wanted to kind of review this. Okay, so we said there's a little hydrogen with its 1 valence electron, and helium has a full outer energy level of 2. And all the elements in family 1 start off with 1 valence electron. And all the elements in family 2 start off with 2 valence electrons. And all the elements in family 3 have 3 valence electrons. Elements in family 4 all have 4 valence electrons. Family 5 are all 5. All the elements in family 6 have 6 valence electrons. All the elements in family 7 have 7. All the elements in family 8 have 8. These elements over here would have full outer energy levels if they could get rid of the valence electrons that I put in red. These elements over here need to add some in. And remember, we're never losing or adding more than 3. So family 1, when they lose that 1 valence electron, okay, it's gone now. What's left are these full outer energy levels that make them like the noble gas. So lithium has electrons now just like helium. Sodium has electrons just like neon. Potassium, now its electrons look just like argon. So it's more stable this way. The same thing. And when they lose this 1 negative now, they become a 1 positive, okay, because they have more protons. So lithium has 3 protons and only 2 electrons, so there's 1 more proton than electron, so now its charge is 1 plus. Okay, now electrons just don't disappear. They go over here to fill up the family 7 elements. When they gain this 1 electron, they're full. So fluorine has 2, and 7 plus 1 is 8. It's like neon. Chlorine has 2, 8. 7 plus 1 is 8, so it's like argon. So they become more, again, like the noble gases, but now they have 1 extra electron, so everything in family 7 is going to be a 1 negative when it becomes an ion. Family 2 is going to lose these 2 valence electrons, and when it does that, it becomes like the noble gases again. Beryllium is like the helium, the magnesium is like the neon, the calcium now is like the argon. But now they have 2 negatives and there's 4 positives, so there's 2 more positives than there are negatives. So everything in family 2 is going to be a 2 positive. So it's the same thing here with magnesium. There's 10 negatives, 12 positives, so there's 2 more positives than negatives. So every element in family 2 is going to be a 2 positive. Family 3 has these 3 valence electrons out here that if they could get rid of them, okay, I'm sorry, I forgot one thing over here. These electrons that family 2 lost are gained over here by family 6. When that happens, 2 and then 2 electrons on the first energy level, then 6 plus 2 is 8. These elements all become like the noble gases. These 2 extra negatives mean that as ions, they have a charge of 2 negative. Family 3 is going to lose those 3 valence electrons that I have here in red. When it loses the 3 negatives, they become 3 positive. So beryllium has 2 negatives. It has 5 protons. So that means it's going to have 3 more positives when it's an ion than it does negatives. The electrons just don't disappear. They're going to be added in over here on the last energy level of the element of the family 5 elements. When they do that, for example, nitrogen becomes more like neon. It has 2 electrons on the first energy level, and then 3 plus 5 is 8, so it's like neon. And same thing with phosphorus. Okay, it's 2, 8. 5 plus 3 is 8, so it's like argon. Okay, and when they have those 3 extra electrons, they become a 3 negative. Okay, so what is the oxidation number? Well, these are the oxidation numbers, the number of electrons that were gained or lost, okay, in order for these to have full outer energy levels. So we're going to write that in. It is the number of electrons that atom lost to become positive ion or gained to become a negative ion. Okay. Now, what are the oxidation numbers for the different families? Okay, I clipped the top of the periodic table we were just looking at so we can see family 1 is a +1. Family 2 is a +2. Family 3 is a +3. Family 4, okay, is 4 plus 4 minus. They usually share, and I said this is where covalent bonding is going to be happening. Family 5 is a 3 negative. Family 2 is a 2 negative. Family 7 is a 1 negative. And then family 8 is perfect. It's not going to gain or lose any electrons, so the oxidation number is 0. So you can see that these oxidation numbers relate to the families on the periodic table. Family 1 has an oxidation number of 1. That's because it's going to lose that 1 valence electron. So family 1, its oxidation number is the same as the family number. Same thing with family 2. When it loses those 2 valence electrons, it becomes a 2 positive. Family 3, the oxidation number is also equal to the family number. In family 4, like I said, we're going to talk about this later in covalent bonding, but it's still the oxidation number is the family number. And in family 5, okay, the oxidation number plus the family number is equal to 8. So the 3 electrons it gains plus the 5 electrons that family 5 had, 5 plus 3 is 8. Family 6 has 6 valence electrons plus the 2 it gains. 6 plus 2 is 8. Family 7 has 7 valence electrons plus the electron that it gains. 7 plus 1 is 8. Family 8 gains 0 electrons, so 8 plus 0 is 0. So the oxidation numbers are directly related to the family numbers because the family numbers indicate the number of valence electrons. So again, family 1, 2, and 3, the oxidation number is the same as the family number. And in family 4 as well. And then in families 5, 6, and 7, it's the family number plus the electrons to get to 8. 5 plus 3, 6 plus 2, 7 plus 1. So in general, what we've learned is the metals lose electrons, they lose negatives, and they become positive ions. Family 4, we're typically going to find out that there's covalent bonding and sharing going on. In families 5, 6, and 7, the nonmetals gain electrons and become negative ions. In the 8th grade, we don't often spend much time on transition elements, but sometimes you'll see a transition element and its oxidation number is indicated with a Roman numeral like I put here. So it says Fe Roman numeral 2. That means that it's an Fe2+, because it's a metal, and remember the metals become positive ions. So now here might be some examples of some elements that you need to find the oxidation number for. And it's always going to be a metal, which is going to be a positive ion, bonding to a nonmetal, oxygen, which would be a negative ion. So in order to find the information, we need the periodic table. I went ahead and put the oxidation numbers at the top of this periodic table. It's the same as what's in this chart for easy reference. Our first element is magnesium. We look on a periodic table and we find magnesium. Here it is in family 2. That tells us it has 2 valence electrons, and its oxidation number is 2 plus. Remember, with the metals, the oxidation numbers in family 1, 2, and 3 is the family number. In family 6, we find oxygen. It's simple as O. It's in family 6, so it has 6 valence electrons, and its oxidation number is 2 negative. And remember, on this side, the family number, the valence electrons, plus the oxidation number equals 8. Our next example is potassium, which is the metal, so it's going to be positive, and sulfur is the nonmetal. The first thing we need to do is locate them on the periodic table. So here we see potassium in family 1 and sulfur in family 6. The symbol for potassium is K. It's in family 1, so we know it has 1 valence electron. In family 1, 2, and 3, the oxidation number is the same as the family number, so it's 1 plus. Sulfur is over here. It's in family 6 like oxygen, so it has 6 valence electrons. I put here that it's the same as the family number. And its oxidation number is 2 negative. And again, I said, remember, this equals 8. Number of valence electrons are the family number, plus the 2 electrons, its oxidation number, equals 8. So again, the oxidation number is directly related to the family number. Now, there's some general rules for naming compounds. Okay. We're only going to name binary compounds in the 8th grade. The prefix bi means 2. Like a bicycle has 2 wheels, or cycles. We have 2 cycles, and the cycles are the wheels. Okay. So binary means 2 names. So how do we write a binary ionic compound? We're going to write the name of the positive ion with its oxidation number first. Then we're going to write the name of the negative ion with its oxidation number. We're going to crisscross the oxidation numbers and drop the signs. We're going to use the root word for the second element and add IDE to the end. Now, this sounds more complicated than it is. We're going to go through an example, and it's easy peasy. Okay, so just like we did before, we're going to look at a metal, which is calcium, bonding to a nonmetal, which is chlorine. Okay, we're going to get out the periodic table. Okay, the oxidation numbers up here for easy reference. Okay, we need to find our first element, calcium. Well, here it is in family 2. Its symbol is Ca. It's in family 2, which means we know it has 2 valence electrons. In families 1, 2, and 3, the oxidation number is the same as the family number. But notice how these are the same, family valence electrons and the oxidation number. Now, our nonmetal is chlorine. So we know it's nonmetal. It's going to be over here on the right-hand side of the periodic table. And here's chlorine, and it's in family 7. Its symbol is Cl. We said it was in family 7, which means it has 7 valence electrons. And its oxidation number is -1. That's the 7 valence electrons it has, plus the 1 it needs to gain to have a total of 8. Now, let's look at the rules for writing the name. It says write the name of the positive ion with its oxidation number. So we're going to write the symbol for the positive ion with its oxidation number, and the oxidation number always goes up above. It's called a superscript. It says then write the name of the negative ion with its oxidation number. So we're going to write the chlorine with its oxidation number -1. Next step says crisscross the oxidation numbers and drop the signs. I'm going to put the symbols over here. I want to show you what happens with this crisscross the signs. So we're going to take the 2 and put it down there, next to the chlorine. So see where it went? Right there, next to the chlorine. And we're going to take the 1, and we're doing the crisscross, and we're going to put it down over here by the calcium. That's it. You take this number here, and you put it down here. You take this number here, and put it down here. Now in a formula, there's not signs. Okay? It just says there's 1 calcium and 2 chlorines in this compound. Now, do we need this 1? No. This is like algebra. Okay? But in the 8th grade, if you write the 1 there, I might have marked it wrong. Now, we also said that ionic compounds are neutral. So let's take a look at the formula. The formula says there's 1 calcium in the formula, and each calcium is an ion, has a charge of 2+. So the calcium has its charge of 2+, and there's 1 of them, so it's a 2+. The chlorine, we said, has a charge of 1 negative. And when we crisscross the number and the sign, we said there should be 2 in the formula. Well, if each chlorine has a charge of -1 and there's 2 of them, the 2 negative 1s make a -2. And earlier in the notes, I said these ionic compounds are neutral. Well, the 1 calcium with its charge of 2+, the 2 chlorines, each with their charge of 1 negative, is a 2 negative. So when you add those together, it's 0. So the sum of the compound is 0. Now, if you didn't get all of that, don't worry about it, okay? But this is the reason why we can crisscross the oxidation numbers and drop the signs, because it's like cross-multiplying, and it makes it automatically a neutral compound. What you need to remember is you take this 2 and you put it there. You take this 1 and you put it there. Now, here's the elements we had: calcium and chlorine. So I just wrote calcium chlorine there. The last step says use the root word of the second element and add IDE to the end. Okay, so the root word is chlor. I'm going to add IDE to the end, and it's going to be calcium chloride. That's it. So we're going to stop here. You're going to practice a few of these in your notes. Okay, so you're really going to need these steps, and then you're going to be crisscrossing the oxidation numbers and putting IDE on the end of the second name. And we'll check in with you next time and see how that's going.